we also come across reflections, and a reflection flips it across the line. So if your original is facing up, but that a value, so this is y equals x squared, if you have y equals negative x squared, well, it'd be the same exact shape, just flip down. One thing that might happen as well is you could have the input flipped. Um, so instead of having f of x, well, let me do it in a different color here. If the parent function is f of x equals x squared, well, all you have to do is f of negative x, and you plug in the negative x. The thing is, whenever you square a negative, it always becomes positive, so it doesn't really change it all that much. This is really, second part, really comes in on higher degree functions. We're not going to work with it much now, but it might come up. Most of the time, all you have to do is take a look at the leading coefficient. So you have y equals negative 3x squared plus 5. And notice that that leading coefficient is negative. That means it's going to open down instead of up. And we already knew that. If the a is positive, it opens up. If the a is negative, it opens down. So let's go ahead and do a couple of these. Example 5, describe and graph the reflections. So describe how the graph of each function is related to the graph f of x equals x squared. So I notice two things. It has a reflection because it's got a negative. It's also got a positive 2, which means it's narrower. So that a value gives you two pieces of information. It's reflected across the x-axis. It's also stretched vertically. Remember, that means it's more narrow. And the last bit is it's translated down 3. So, what does that graph look like? Let's draw some little axes here. So, the normal graph, again, the blue ones you don't have to draw, just sometimes can help you really get a good feel for what it's looking like on your page. I'm going to flip it down so I know it's going to be pointing in the down direction. I'm going to make it more narrow, right? And then I'm going to slide the whole thing down 3. So that vertex is, I'm going to move it down 3. Then everything else is going to be narrower and down. And there's my graph of g of x. Now, if you could see, I didn't actually like plot any points or anything like that, but the whole idea is, what's the general shape of this thing supposed to look like? And if you can find the general shape, then you're like halfway there, right? If you need exact points, that's what calculators are for. Or, sometimes you got to do it by hand anyways. All right, for part B, let's take a look here. We have a negative 4. Oops, that's supposed to be in blue. I've been highlighting my A's in blue. So that's going to be reflected across the x-axis. It's going to be stretched vertically. And then looking at the inside, we have a +2, which means it's going to move left 2, because we do the opposite when it's inside the parentheses. +1 means up 1. So, what does my graph look like? You know what? I like that axis. I'm going to draw. So, because I know it flips down, so I'm just going to draw um, a lot of space down below. Now, I also want to have space to the left because I know the graph gets shifted to the left. So normally the vertex is at 0, 0, but it's going to move left 2 and up 1. There's my new vertex. And I know it's going to go down, and I know it's going to be very narrow. So I draw it down and very narrow. Now what I'm going to do on this one to kind of mix things up a little bit, in green I'm going to draw the exact shape with some actual points in it. Let's see here. -4 times, oh, let's do -3 plus 2 quantity squared plus 1. What do I get? -1, -3. So you can see that's pretty close there. And then, well, let's plug in -4. See what happens. We get -15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So maybe I wasn't quite narrow enough, but if you take a look at my graph that I actually calculated out by hand, it is pretty close to what I'm doing just by sketching it out real quick. And that's something you get better and better with at time, but this goes to show you why learning transformations are so powerful. If you can sketch it quickly, then you can understand what the graph is supposed to look like very quickly without having to calculate out a bunch of points.